Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is longest substring without repeating characters. So it's a medium level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. That given a string S, we have to find the longest substring without repeating characters. Right? And what is a substring? Substring is a contiguous non-empty sequence of characters. It has to be contiguous. Now let's see an example to better understand the question. Like we are given with an input S, A, B, C, A, B, C, B, B. We have to output the longest substring without repeating characters. So A, B, C is the only longest substring from this string which without repeating characters, and it's the longest one. Right. So all the other substrings can be longest, but they are not. They would not be any like non-repeating characters. Let's see how we can solve this problem. So one way to solve this problem is a brute force, right? One way to solve this problem is a brute force way, right? Like for we find each substring, right, using two for loops, right? So I starts from 0 to n minus 1, j will start from I plus 1 to n minus 1, right, to create all the substrings. So it will be like AB, ABC, ABCA, ABCAB, then BC, and so on, right? So in this way it will be on square for finding all the substrings into, right, into order of n, right, into order of n. This order of n will be to find the duplicate characters, right, in each substring. So the worst case can be the substring can be n of n length, right? The substring, like this string itself is a substring, so we might have to so we have to calculate the duplicates in this string as well. So there will be 3 loops. So there will be 3 loops. So the order of time complexity will be order of big O of n cube. So can we reduce this time complexity? Yes, we can use a sliding window technique. So why we can use sliding window technique? Because if we consider a substring, suppose Sij, from index I to j, right, then we have already, so suppose this is an index from I to j, and we are already checked from I to j minus 1 for this substring, right, whether it has duplicate characters or not. So the only character we have to check is for the jth character that we have to check, right? So there is no need to check the characters again. So in this way we can use the sliding window, right? So what is a sliding window? So sliding window is an abstract concept, so is where it is commonly used in array or string problems. So it's basically a window, right? It's basically a window, and it's a window of a range of elements in the array or the string, which is usually defined by the start and the end indices, like I and j. So I represents the left boundary and j represents the right boundary. These are the two boundaries, and this sliding window slides in a certain direction. So suppose if I slide this window to the right by one element, then it will shift to I plus 1 and j plus 1. So suppose I have 1, 2, 3, 4 as current the array, and I have the window as this one, like I pointing to 0 and j pointing to this is I and this is j. So if I do one element right slide, then the new sliding window will be this much. This will this like I plus 1, right? This will be I plus 1 and j plus 1. Coming back to the question, we can use the same concept, sliding window concept, in our example or in the question. Now let's see the dry run of this example with the sliding window concept. So we will to represent our boundaries of the sliding window, we'll have I starting from 0 and j starting from 0, right? J starting from 0. So at the start the sliding will be of length 1. Now we will also maintain a resultant which will be the longest substring, resultant array that will be the longest substring without repeating characters, and we will use a map, right? If we are at jth position and we have to check whether the jth is a duplicate character or not, then we have to maintain a certain data. We have to maintain the frequency of the characters from I to j minus 1 in a certain data structure, and the data structure we will use a map where key will be the character and value will be a integer which will maintain the frequency of that key. Okay, so we'll start with j equal to 0, that is a, and we'll add a in the map because a is not present and the frequency as 1. Now the result, the length of the sliding window will be 1. How? We will do j minus I plus 1. So j is 0, I is 0 plus 1, that is of 1 length. So sliding window is of 1 length at the start. Now we will increment our j pointer. So earlier j was pointing to this, now it will point to 1, 0, 1, 2, 3, 4. So j will point to first index. Now again we'll check b is not in the map, so we'll add b with the frequency 1. Again we'll calculate the sliding window. So 1 minus 0 plus 1 will be 2 because j is 1, I is 0, 1 minus 0 1 and addition of 1, that is 2. So the new length, sliding window length is 2. As you can see, AB is till now this AB is the longest substring without repeating characters. Now again we will increment j, that will be pointing to 2. Now again C is not in the map, so we'll increase frequency, and now the new length will be 3. Now again we will increment j will point to 3. So 3 is a, we will increment the frequency because a is already present, so 2. Now the frequency has increased from 1 to 2. So now we have to decrease the sliding window size, right, by incrementing the I pointer. So I is pointing to 0, right? I is pointing to 0, and our current sliding window is of length of this much, right? But this is not the correct length for the resultant because it has a duplicate character. So what we will do, we will start from the ith pointer and we'll decrease the frequency of each character from the backward direction, like pointed by I pointer. So it's pointing to 0, so we'll remove a from our sliding window and we will decrease the frequency from 2 to 1. And now we will check the new sliding window. Now we'll check the new sliding window, that is BCA, whether it's duplicate free or not. Yes, it's duplicate free, right? But the size is 3 only, so there is no impact on the size. Now we will again increment the sliding window. So now here the I will point to 1, right? And we'll increment again the j. So now our sliding window has this much from B to B. Now again it's BCAB 4 length, but the characters are repeating. So we have gone to B. Now B is 1, we'll increment the frequency to 2. Now the frequency has increased from 1 to 2. Now again we have to remove from this sliding window the character B to make it frequency 1. I is pointing to 1 from the previous increment. Now we'll check the character at index 1, right, as I is pointing to 1. So it's B. So we will remove B from the sliding window, and now our current sliding window will become CAB. So as we have removed from the sliding window, we'll decrement the frequency of B to 1, right? And the new sliding window, the sliding window without the duplicate entry of B is 3, and the maximum is also 3, so there is no impact. So 3 is the, and we are now we are no more characters, so we have got our result as 3. So 3 is the max length of substring with no repeating characters, that is ABC. So let's see another example with ABC CBB. So similarly we will maintain I equal to 0, the left boundary, and j equal to 0 as the right boundary for the sliding window, and the resultant will store the longest substring of, with the no repeating characters. So we will first see, first we have A, right? So A is not in the map, so we will add A in the map with the frequency 1, and the result will have 1. So 1 is the currently as the longest substring with no repeating character, that is A. We'll increase our j pointer to 1, and our sliding window will increase from A to AB. The character B is also not in the map, so we'll add the in the map with the frequency 1. Now we'll increase the length of the substring, that will be 2, because it has 2 characters and both are distinct. So now we'll again increase the j pointer, that will be 2. So now the sliding window length is 3, right? It increases from AB to ABC. So C is also not present in the map, so we'll add C with the frequency 1, and we'll increment the result to 3, because now the size of the window is 3 with the non-repeating characters. Now we will again increment j, so j will now point to 3, and it will include A, B, C, C, right? Now if we see this sliding window, now it has a repeating character. Now it is a repeating character. So what happens is, as soon as we add C, right, now the frequency of C has become 2, right, greater than 1, which indicates it has a repeating character, right? As also it's evident that C is repeating. Now what we have to do, now we will decrease the length of the sliding window, right? We have to remove the duplicate character, because we have to maintain our sliding window with the maximum characters, but they should be non-repeating. Now we have to decrease the length of the sliding window, right? So now here comes the role of the I pointer, right, the left boundary, right? This is the left boundary. So now we have to decrease the size of the sliding window until we remove the duplicate characters, right? So currently I is pointing to 0, so we will make I equal to 1. We'll increment I equal to 1. We'll keep on incrementing the I till j, right? Either it reaches the j pointer, or we have removed a duplicate character, right? So first we will increment I 0 to 1. So now the j was at 3, right? This j was at 3 and I was at 0. So now when we have increased I to 1, our sliding window has become this much, right? This is our BCC, right? So here J is 3. Result has, till now the result has the maximum 3 non-repeating character, that is ABC, that we saw. Now when we have incremented I equal to 1, it means we have removed the A from our sliding window, so we'll decrease the frequency of A, that will be 0, right? But still the frequency of C is greater than 2. We again will decrease the size of the sliding window. So now the sliding window will again increment the ith pointer. So now I will become 2. I will become 2, right? I will become 2. J will remain as 3 and result will be having 3 because the maximum we saw was 3. Now we have reduced our sliding window, so it will be of this length. So it will be only 2 characters C and C, right? And we'll reduce the frequency of B to 0. Now again we saw that C is, the frequency of C is greater than 1, is still greater than 1. So what we will do, we will again increment I, to 3. J will remain to 3 and result, as we saw, it's 3. So now the sliding window is only this much, only character C, right? Only character C. And now we will decrease the frequency of C to 1. So now the sliding window has only 1 character, right? And you know, the maximum when we were decreasing from 3 to 2 to 1, we were decreasing the size, the length was decreasing. So we don't have to update our result, right? Because it has to be the maximum of all the substrings. So now this is the max of all the substrings, right? So now there is no duplicate in the sliding window. So we'll increment our J equal to 4. Now J will point to 4. Now I is at 3 and J will point to 4. J will point to 4. The J character is B. So now we will increment our character B frequency from 0 to 1, right? Now the sliding window has become CB of length 2, right? Of length 2. But we have already the result as 3. So we will not update with 2 because 2 is smaller than 3. Now again, because the sliding window has unique characters, now I equal to 3 as it is, and we'll increment J to 5, right? So I will be pointing to 3 and now J will become 5. So the sliding window will become CBB of 3 length, and so we have the new character as B. So we will increase the frequency of B to 1, from 1 to 2. Now from 1 to 2 it is greater than 1. So we have to decrease the length of the sliding window, right? So we will again increment our I pointer, right? We will increment our I pointer. So I was pointing to 3, right? I was pointing to 3. Now I will point to 4, right? I will point to 4, right? And J was pointing to 5. So I will point to 4 and the sliding window will reduce to 2 characters, right? We will remove C from the sliding window, right? So now I has become 4 and J is equal to 5. Now we will decrease the frequency of C to 0, but the frequency of B is still 2, right? It's still 2. So the sliding window has still duplicates, right? And the result will remain 3 because this is the maximum so far. So we'll again increment our I. Now I will become 5 and j is 5. So now I will be pointing to 5 and j will also point to 5, right? And the sliding window will have only one character, and the result will remain same, that is 3. And as we have removed b from the sliding window, we will decrease the frequency of b to 1, right? So now the j has reached the end of the string. So the maximum so far in the result is 3. So 3 is the maximum length of the substring with non-repeating characters. So let's read the code part of it. So we have maintained a map data structure to maintain the frequency corresponding to each character, right? So that we can apply sliding window concept, and we have our left and right pointers as the boundaries for the sliding window, and result will store the longest substring without repeating characters. We'll loop till the right boundary reaches the end of the string, and we'll take each character by character, and we'll check whether it's present in the map or not. If it's present in the map, we'll increment the frequency, otherwise we'll make a new entry in the map. If the count of any character is greater than 1, if the frequency becomes greater than 1, so what we have to do is we have to decrease the size of the sliding window from the left, right? So we will take out the characters from the left, and we'll start decrementing the frequency in the map, and we'll increment the left plus plus, i.e. decreasing the size of the window, right? So this ith pointer decreases the size of the substring by moving from left to right, and this helps us in removing the duplicate character. So we will do this while loop till we don't have any duplicate character in the sliding window. So result is the maximum of result and right minus left plus 1. So this j minus 0 plus 1, that is we were maintaining at each increment of the j, that will give us the maximum or the longest substring, and then we will always increase our boundary of the sliding window with each character. And finally, once this loop is over, when there is no more character to go, we'll return the result. So let's run this program. So yeah, test cases are accepted, so the solution is correct. So let's see the time complexity of it. So the time complexity for this solution will be order of n, more specifically order of 2n, because suppose this is a string and I is at 0 and j is at the last character, like suppose n minus 1. Now and this last character is a duplicate of j minus 1, right? So if these are only the two duplicate characters, now the I has to iterate again each element to remove this duplicate character. So once j would have gone from 0 to n minus 1, and now I would also go from 0 to j minus 1. So the worst case, each character will be iterated 2 times, so giving the time complexity as order of n approximately, because we ignore 2. So I hope you like this video. If you like this video, please share and subscribe. Thanks for watching. Bye.